Clearing equations of fractions. This is a topic that is always challenging for Algebra 1, Math 1 students. And so this is a video to provide you with extra examples to hopefully realize the process here. So look at my first example. I'll call it example A. I'm going to say 7 over 2x plus 1 over 2x equals 3x plus 3 over 2 plus 5 over 2x. So the most difficult part of this equation is definitely the fact that there's fractions in it. So there's a couple different ways you can go about it. You can combine some like terms and do different things, but really I think the best thing to do is to clear the fraction early on in the process. So what I'm going to go ahead and do is group both sides. Okay. And what's tricky for most people is finding a common denominator. This one's actually pretty easy. It's why we're starting with it. But I'm going to look at the denominators, the bottom parts of the fractions, and I have to pick the number that they have in common. Well, they're all 2, so it's pretty easy to spot that this one's going to be a 2. So I'm going to multiply by 2. Okay. Well, realizing that when I say I multiply both sides by 2, these are fractions. I want to think of this as 2 over 1. Okay. And I'm about to use my distributive property here. Okay. And this has to get distributed to this one as well. All right. So keep in mind, how do I multiply fractions? I multiply the numerators times the denominators. So that's 14 over 2x plus 2 over 2x equals 6x plus 6 over 2 plus 10 over 2x. All right. And if I multiplied by a least common denominator, or any common denominator, the fraction should reduce to even integers, so even whole integers. So we're looking at 7x plus just x, as 2 divided by 2 is 1, equals 6x plus 3 plus 5x. And this is a much better looking question. So this is going to combine like terms over here. I'm going to combine like terms over here. All right. I'm going to go ahead and get my variables on the same side. So it's going to be negative 3x equals 3. I'll divide by negative 3, and x equals negative 1. All right. So you can see here I'm trying to clear the fraction so that I have something that is much easier to work with. Let's try another one. Example B. And I'm going to say 5 over 3 plus 2 over 3x equals 25 over 12 plus 5 over 4x plus 3 over 4. Okay. So I'm looking at all my denominators. I'm going to list the different numbers that I have for denominators. So I've got 3, 12, and 4. Okay. So I'm going to kind of list those over here. So I'm going to say 3, 4, and 12. So those are all my different denominators. Got 2 3s. And when I'm looking at a least common denominator, it's like it's a multiple. Okay, and multiples get bigger. So I want to find the one they have in common, which is basically saying what number through multiplication of itself will they turn into? Well, let me show you what I mean by that. So multiples of 3 are 3, 6, 9, 12, 15. Multiples of 4, 8, 12, 16. Multiples of 12, 24, 36. Those are multiples. I want to see which one do they have in common that's the smallest. So if you look at it here, for these two, it looks like the most common one is going to be 12, and this is a 12 also, right? So that is my LCD. That's what I'm going to multiply by. Remember, I got to do it just to the numerators when I distribute that 12 in. Okay. So some of these numbers are going to get kind of large, but we can do it. 12 times 5 is 60. So this is 60 over 3 plus 24, right? And then over here, we're going to get 25 times 12, it's 300, over 12 plus 60x over 4, and then multiplying just the top, right? 36 over 4. Okay. Now, like I said, everything should reduce. Everything should reduce here. So this is 20 plus 8x equals 25 plus 15x plus 9. So everything reduced. Okay. So look and see if there's any like terms to combine. So I'll say 20 plus 8x, 15x plus looks like 24. All right. Sorry, 34. Okay, 34. Now I'm going to go ahead and subtract 8x to both sides. Okay. Cross here, and I'm looking at 20 equals 7x plus 34. I'm going to subtract 34 to both sides. And I'm looking at negative 14 equals 7x. Kind of running out of room here, but I would divide both sides by 7. I'll come over here and do it, and x equals negative 2. Negative 2. Alright, let's try one more in this video. So we're looking at, call this example C. 4 over 5x minus 3 over 4x equals 3 over 10x minus 1. Okay. So kind of coming to give myself a little bit, I got to look at the multiple. So I've got a 5, a 4, and a 10. And a lot of us can do this in our head, and that's fine. I'm just kind of writing it out so you can see what I'm thinking here. Okay, so list the multiples. So that's 20, 30, 40. Okay, 8, 12, 16, 20, and then 10, 15, 20, 25. And if you look at this, it looks like it's going to be 20. All right, 20 is the number that they have in common that happens to be the smallest. Right, and that's not too hard to tell just by looking at the numbers if you're really good with your math facts or your multiplication. So now that I've got that figured out, I'm going to go ahead and multiply by 20 to both sides. And remember, think of it as over 1. Okay, and then I'm going to use my distributive property. And I'm looking at 80x over 5 minus 60 over 4x equals 60 over 10x minus, this is just 20 times 1. Okay. Now, like I said, hopefully if I multiply by the right type of number, everything should reduce and the fraction should go away. So this is going to be 16x minus 15x equals 6x minus 20. If I combine like terms over here, that's just x equals 6x minus 20. Okay. I'm going to go ahead and get my x's on the same side. So I'll subtract the 6x to both sides. And we get negative 5x equals negative 20. Divide by negative 5. And x equals 4.